Okay, hi. Now we finally made it to almost the end of properties of matter, and the very last lesson that we have is a general overview of kinetic theory in terms of the three gas laws, or well, the three gas laws in terms of kinetic theory, I should say. Now a few lessons ago, I was talking about kinetic theory and what that meant for pressure, and we looked at how the gases were made up of particles, and when the particles were contained within a container, they would strike the container walls, they would strike each other, they would move about in a random direction, and the number of collisions per second, we didn't really quantify this. We're not going to quantify anything. This is what we would call a qualitative description. And so the number of collisions that the particles make with the container walls will relate to the pressure that the container feels, or the pressure that the gas exerts on the container walls. And this is due to the fact that of the billions of particles and then of the billions of collisions that are made, each will impart a small force. And so if we remember, pressure is force per unit area. And so we'll see that that pressure is maintained by the constant striking of the container walls. But what does it mean in terms of our gas laws? And as I've been going through the gas laws and doing the teaching, I've been trying to explain the kinetic theory behind each of them at the same time. But in this short clip, I'm just going to bring it all together and explain some of the important things that you need to do when answering a question on kinetic theory. So we'll have a really quick pit stop at the learning intentions, just to look in 16.7, the relationship between volume, pressure and temperature, using qualitative info in terms of kinetic theory. So that's what we're talking about here. So from this point, we'll look at the course notes and we can explain that in a bit more detail. Page 25 of the course notes then. So we can say gas laws can be explained by considering molecular motion. So the particles of the gas, they're moving around in a random direction, and what we're really trying to get you to do here is, if you see these bullet pointed statements, then you've got to start trying to talk in these kind of terms. It's going to make it easier. I'm not going to say learn these by rote, write them down 1,000 times and just learn them off by heart, because it's a reasonably straightforward concept to understand. And it makes perfect sense. So you're having these particles, they're moving around as you saw in the animation, and they will strike the container walls. But as we decrease the volume, then the molecules, they're moving at the same rate, so the same velocity, but because there's less space for them to move in, they make more collisions per second with the container walls. And so if we're looking at giving an answer in an exam question, then we're going to start with saying that, well, the volume decreases. And because the volume decreases, they make more collisions with the container wall. So that's the really crucial bit, more container. And so the force increases. And so the pressure increases. Okay? So as the volume decreases, more collisions with the container wall per second, and therefore the force applied to the walls increases. And please be specific, don't say the force increases, but the force that the particles apply to the walls of the container. And try and put it into concise but yet accurate terms. And if the force applied to the container walls increases, then the pressure must increase as well. Now, if we're going to keep volume constant, and the next two will be very similar to this, but with an increase in temperature. With pressure law, you increase temperature, and the pressure increases. With Charles's law, you increase the temperature and volume increases. With an increase in temperature, that's that first bit. So as temperature increases, EK of the molecules increases. So EK increases. Please remember that. EK increases, and therefore they move faster. If they're moving faster, they're going to hit the container walls harder and more often. So here we're going to say harder and more often. If they hit them harder and more often, then the force is going to increase, which is going to increase the pressure. Okay, so hopefully you can see it's reasonably straightforward. There's nothing really to understand here. It's common sense, but it is getting you to remember and how to write this in a concise yet accurate way. Charles's law, so we're going to start off again. You increase the temperature, then EK of the particles increases. They move faster, and so they do start striking the walls harder and more often, but in order to maintain the pressure, the gas must expand to give them more room to move in. And so the net pressure, what am I saying? The net pressure stays the same. So gas must expand to maintain pressure, and therefore the volume increases. And that's kinetic theme. Okay, so there will be a number of different assignments on this, and you're going to be working through the remainder of that for a while. But this is now the last lesson on properties of matter, and that is us finished the unit. Okay, well, thanks for watching. I hope you're all well, and I'll see you soon. Bye bye.